Okay, going back to this. So again, we know that I made this a bit too big. There we go. So if I look at this again, we know that those are not going to change on all of those. Oops, we got it backwards. The 0 is actually right there. So 1, and the fact that again this is behaving like x cubed times x squared x to the 5th, the fact that this is odd, well, I know this has multiplicity 3, the yellow, so since this is up there, it has to look like, that's how a cubic look like. And the fact that x equal 1 multiplicity 3 indicate around that it should look like a cubic, and it does. And x equal negative 2 multiplicity 2. So here, I know the end behavior is going to look like that, but to make it look like a parabola, don't you have to come back down? What is the y-intercept? 0. Negative 1 times 4 is negative 4. So everything should match. Everything complement what you're doing. Otherwise, something is wrong. And if the intercepts don't match, then you might have made a mistake. Go back and fix it. Make sure that that looks like a cubic. If you make it a straight line, you won't get credit for it. How about here? Well, we know x equal 1, x equal negative 2. We're getting the hang of this, hopefully. This behaves like x cubed times x cubed, x to the 6th, like a parabola. Parabolas look like this. The fact that this is cubic tells me that I'm going to make it look like a cubic. Well, if it's going to point up, that's how a cubic looks like. Around that 0, it should look like a cubic, and it does. And since this is a cubic, and I know from the end behavior, the only way I could make that a cubic, again, it doesn't look like a positive cubic. That we have no control over. What's missing? What's the y-intercept? Let x equal 0. Negative 1 cubed is negative 1 times 8. That's negative 8. Negative 2, 4, 6, and negative 8. You could scale this any way you want. Just make it as smooth as possible. And there's the graph. I don't need this anymore. I already matched what I need. So without the end behavior, we can't get those correctly. And how about this one? Well, let's see. What are the zeros? We have 3 of them. We have x equal 1, yeah. We have x equal negative 2. And we have x equal 0. I am going to shift that scale just a bit up. I want it to be... There we go. Perfect. So, if I'm really looking at this, I have x equal 0 multiplicity 1, x equal 1 multiplicity 1, x equal negative 2. Here I'm just summing up what we did, so I picked those at random. This behaves like x times x, x squared times x cubed, x to the 5th. So x to the 5th look like that. I forgot to make one of them negative. Let's make that one negative, just for the heck of it. Alright. Okay. And we are done. Okay. So how does that work? Well, let's see. X equals 0, x equal 1, and negative 2. Let's go from right to left or left to right, it doesn't matter. This 0 has a multiplicity of 1, so this is going to look like a straight line. It has to go through the other intercept. This has multiplicity 1, like a straight line, there's a straight line. And do you notice that this has a multiplicity 3? So this, when it comes down, I need to make it look like a cubic. That's why it's important to do this part first, and then you say, okay, you know what? Let's make this a smooth curve. So let's go straight up, and as much as you need to make it look like that. There you go. It doesn't matter how high you take that. No big deal. There it is. And here, because the y-intercept happened to be a 0, how about here? Well, again, this behaves like negative x times x squared, that's x cubed times x cubed, negative x to the 6, like an upside down parabola. But I know the zeros are not changing. They're the same. So graph must pass through these points or touch these points. X equals 0 multiplicity 1, x equal 1 multiplicity 2, x equal negative 2 multiplicity 3. So since this points down, the only way to make it look like a parabola, but the graph has to go through the other intercept. Do you see that this has multiplicity 1, straight? And do you see that this has multiplicity 3? There you go. So around this 0, I should be looking at something that looks like a cubic. How about this graph? Well, it crosses at 0, 1, and negative 2. Multiplicity 3, multiplicity 2, multiplicity 2. So x equals 0 multiplicity 2 is going to look like a parabola. X equal negative 2 multiplicity 2 is going to look like a parabola. And x equal 1 multiplicity 3 is going to look like a cubic. This is dominated by x squared times the x cubed, that's x to the 5th, x to the 7th, odd. Starting right or left, if I'm going to go from the left, I need to make that look like a parabola. It has to go through the other intercept. I have to make that look like a parabola. And this has to look like a cubic. There you go. So when I look around that 0, it should look like a cubic. And when I look around that, it should look like a parabola. It does. And when I look around that, it should look like a parabola. And it does. And the last 3 examples I have, if I want to graph this, and those are simple because I could factor them. The rest of the chapter is how to factor a polynomial y so you could graph it. Well, I know this behaves like x to the 4th. Got it. What are the zeros? X equals 0 and x equal negative 4. X equals 0 multiplicity 3. X equal negative 4 multiplicity 1. Okay, well, since x equals 0 multiplicity 3, this 0 must look like a cubic. The fact that this is up here, it looks just like y equal x cubed, my traditional y equal x cubed, a parabola, and it's minus. Now, oops. So around that 0, it should look like a parabola. And this is this is multiplicity 1, so I just have to go through that point and make it look sort of like a straight line. Done. That's it. How about here? This does factor. That is x minus 9 into x minus 4 squared. That is x minus 3, x plus 3. I think you're going to like this one. X minus 2, x plus 2. There are 4 intercepts. There is 2, 3, negative 2, negative 3. This behaves like x to the 4th. These all have multiplicity 1. So it's going to cross like a straight line. Straight line. What's the y-intercept? Let's say that's 36. And you're going to cross straight line and a straight line, and there it is. And how about this? If I factor x cubed out of that, 8 out of that, that would be x minus 2, and this is x cubed plus 8, x minus 2. This is x plus 2 into x squared minus 4 minus 2x plus 4. This has no solution in R. What does that mean? That means this doesn't contribute anything to the graph. This is useless. I doesn't exist. We don't graph I in this class. These are the only two. X equal 2 and x equal negative 2 are the only 2 points that will show, the real points that will show on this graph. Well, I have an intercept at negative 16, and this behaves like x to the 4th. Multiplicity on each of is a 1, so I cross straight and straight. And it's this as if it doesn't contribute anything to the graph. And that's pretty much what this section is all about. This is really the entire chapter. The whole goal is to graph a polynomial. We're going to learn how to factor polynomials that do not factor traditionally. That's not as bad as it sounds.